What's up? Welcome to 2022. Yeah, boy! In this lesson, we're going to be doing exponents. The remix. Before we start, just a few things to point out. If you need assistance, it is your responsibility to ask. It is not my responsibility. It is yours. You are not allowed to disrupt anyone learning. Otherwise, you will be punished. You are responsible to complete all tasks in a timely manner. We are being monitored throughout the instruction. Again, as the video is being played, I am walking around monitoring what's going on, and of course someone's monitoring me as well. So if you're not taking care of business, of course it's duly noted. I may just be in your zone and probably say something to you about it, but other than that, I'm not making a deal out of it because you guys know better. Alright, in this lesson, it's all about those prime and composite numbers. Not really. Exponents, law of exponents, and exponents. The remix. I do apologize that I can't be loud and cray-cray at this moment, but I'll do the best I can in this video. Prime numbers. A prime number has exactly two factors, one in itself. It is also only divisible by one in itself. A prime factor is a factor that is a prime number. Any prime numbers that can be multiplied together to give you the original number. So let's go into these. You see that 2, 3, 5, 7, and 11. Those are prime numbers. Why are they prime numbers? Because in terms of 2, you only get 1 times 2 to give you 2. There's no other factors to give you that. And also, that's it for 2. So for 3, it's just 1 and 3. And just to let you guys in a little secret, mathematicians don't really consider 1 to be a prime number. I do, because there's only just 1 times itself. But that's probably why mathematicians feel that 1 is not a prime number. So, just do it like that, my people. Let's do 17. Well, only 1 times 17 gives you 17. And when you divide them, 17 divided by 1 gives you 17. So that's it, my people, about prime numbers. And the only reason why I'm mentioning them very briefly, because you're going to see a little bit of that. Also, it's a good review for the homework that's going to be given based on what we did at the end of the previous semester. Composite numbers. Well, they are the opposite of prime numbers. For example, 6. 2 times 3. Those are prime numbers. And also 6 times 1. See, more than just 2 factors. They give you 6. So, just like that. Also, when you divide, 6 divided by 2 gives you 3. 6 could be divisible in so many ways. 6 divided by 3 gives you 2. 6 divided by 1 gives you 6. So, a lot of ways that you could get this into. A composite number. Prime factorization. The prime factorization is a way of expressing a number as a product of its prime factors. We did this before, and let me show you why and how. So let me give you an example of a number, 20. So if we broke it on down, people went to 10 and 2. Well, 2 is a prime number, so you could just leave that as is, but 10 isn't, because you got 5 times 2. As a result, you broke it down, and that is prime factorization. Now, what we did for the previous semester is we broke down the square root of 20. So again, we was looking for perfect squares as we break them down into prime numbers. So the square root of 4 and the square root of 5. You broke that down, you know the square root of 4 is what? 2, because 2 times 2 is 4. So 2 and the square root of 5. Bam. And again, prime factorization, prime and composite numbers, not going to be really important enough in the lesson, but you want to see that again in terms of your homework. And also, this is an Algebra 1 topic that you kind of need to have a good handle on. All right, my people, let's go further into this lesson. Exponent review before exponent laws. Now, you guys are really familiar with what an exponent is, and you know it is used to express repeated multiplication of a number. Y'all have to forgive my dog. He's chirping. Alright, so let's do it. For example, you know if I give you the number 25, that's just saying 5 times 5, which you write as 5 to the power of 2. 2 times 2 times 2 equals 2 to the power of 3, which is essentially just 8. So that's what you know about the exponent laws. The exponents itself tell you how many times the base is multiplied by itself. Like in this case, 2 is the base. 5 is also the base. So you know those already. And you know that any base by itself is the base to the first power. So you know these things already. We had a discussion about it, we talked about it. You guys did pretty well on this session of the midterms. So let's move on. Alright, y'all. This is what I want you guys to do. Find the area of the square, and the volume of the cube. I'm going to give you 2 minutes to try this out. Now, this is you doing it independently. It's okay if you get it wrong. As long as you are doing it and giving me honest effort, that's fine. There is no need to go look stuff up on Google and copy the answer, stuff like that, because you guys are fully aware I'm not a big fan of academic dishonesty. Now, I might not hear the phrase, I don't know. You know something about this. So, 2 minutes, pause the video. Let's go and pause that video. Welcome back. The answer should be, for this guy, for the square is 4 times 4, which we could write this as 4 to the second power, which of course you know is to be 16. The cube, of course you know this is a third dimensional shape, so it's going to be 4 times 4 times 4, and that's going to be 4 to the power of 3, which you know the answer to this is 64. Alright, multiply integers. This right here is very important to know about, people, because we're going to be dealing with this. And I know when we did this lesson in the previous semester, we didn't really deal too much with negative integers, except for the exponents. But even then, we didn't go too far into it. So when you here are some rules that you have to recall. Going back to your knowledge of integers, when you multiply a negative number by a positive number, then the product is always negative. But when you multiply two negative numbers, it's always positive. So what do we know is about when we multiply by one negative, and then when we multiply by two? Well, you multiply by 1. What is 1? What do we know about number 1? It's an odd number. What about 2? 2 is an even number. So we could assume that if you have 4 negatives, they're going to be positive. If you got 5 negatives, you're going to have a negative answer. So an odd number of negative signs, you're going to be negative. So if I have 7 negative signs, I'm going to have a negative answer. If I had 9 negative signs, I'm going to have a negative answer. But if I have 10, 20, 14, 12, 22, 28, 30, 36, they are all even numbers, so my answer is going to always be positive. Alright guys, in this particular assignment, this is partner work, so I want you guys to figure out these few problems. Going back to the knowledge with the negative integers that I discussed earlier. I give you guys 2 minutes to work with a partner, one person next to you. Go ahead, get started, and this video is paused. Welcome back. Now let's go ahead and discuss these answers already for us. So, we know from previous information discussed it, that if I have a negative number and the exponent is positive, it's basically telling me like this 12, I have 12 negative ones. So I'm multiplying 1 to itself 12 times. Only thing this saying is that since it's even, 2 negatives cancel out. A odd makes it negative, but another even makes it positive. So that ends up being positive. Again, because it's a 12 negative ones, 2 negatives make a positive, so it's go negative, positive, negative, positive, negative, positive, and you keep going till you get to 12. And that's how you know that. positive. So what about negative 1 to the 13th power? Well, that's negative. And forgive my handwriting. Y'all know my handwriting's bad. Alright, so let's read the statement. An n is a positive even number, even, then negative 55 to the n power is going to be positive. Because you know you got even number negatives, they all cancel out. So if n is a positive odd number, odd, you know it's going to be negative. Again, going back to that basic statements. So if you guys are ever struggling with this, I could give you a little calculator. You could multiply a negative number times another negative number, you're going to know that it's positive. But you times that positive by another negative, it's going to be negative, and then you multiply again by another negative, it'd be positive. So, in case we need to go that far, I would do that. But in the meantime, let's move on. Alright, now this is independent work. Going back to the very beginning about how we write stuff in exponential form, I'll get you started on the first one, but the other three, you will have to do that on your own. This is, again, no group work, not working with a person, you figuring it all out. So I'll do the first one for you. So I got 5, 1, 2, 3, 4, 5, 6. So I got 5 to the 6th power. So at this point, video's going to be paused. You work this out alone. Monitor, and I will assist along the way. Again, if you are doing anything not related to what I'm telling you, independent work, that will be subtracted from your participation grade. Pausing the video now. Welcome back. So let's go ahead and discuss these answers. So the second one right here is 4 to the power of 7. Third one is going to be a to the nth power. And then the last one is going to be 4.3 to the power of 13. Not bad. Let's move on, shall we? Alright, guys. With the law of exponents, we know what they are. We did them. We talked about them. The only thing that we didn't do too much of is give them names. Multiplying powers with the same base. And if you want, you could change the names of these to your likings, because as long as you say multiplying law of exponents, you could say that, or you could say multiplying powers with the same base. Doesn't really matter. As long as you are saying multiplying with the same base, that's fine. And you know, when you multiply with the same base, you just gotta simply add the exponents. And here's a lovely example right here. So, divine powers with the same base, or you call it the division rule of exponents, however you see fit. We did this, and we know when we see that, we gotta subtract. Find the power of the power, or the parallel of exponents. The only thing we have to do is just multiply. That's all they're saying. Just multiply. What about the negative exponents? You could say negative rule if you want to. It really does not matter. And from that, when you see a negative exponent, you write it as a fraction. What about the zeroth exponent? Well, you know for a fact anything to the 0 power is going to always be just 1. So, again, we know these. We're just going to use them through and through. All right. This is an example that I would do with you. All right. So no need to try to figure this out on your own. I may make you try to figure out one on your own, though. I still haven't decided which. So let's get to it. You notice that when we look at these bases of the first one, you know that these bases are not the same. So when you are in a situation where the bases are not the same, you want to learn how to rewrite these into those primes, or to match it to the same as the smaller base. So 2 and 4. So you know 4 is the bigger number, so you gotta break that down into 2. So we know that this is 2. But how many 2's does it take to get me 4? 2. So 2 to the second power. And then there's 2 to the 7th power. So let's rewrite this. So we got 2. I'm working the denominator, by the way. You got 2 to the second power, because that's how we rewrite 4. Times 2 right here. Over 2 to the 7th. So using the power rule in the denominator, I could rewrite this as 2 to the 4th, and then the top 2 to the 7th. All right. At any time that I'm going too fast, you could always, watch the video at home and slow it down, or just ask me a question. So 7 minus 4 equals 2 to the 3rd power. All right. That was a little bit of work, but we noticed that before I could subtract, I had to rewrite it, and then I had to use another law before I could get to the final answer. So I'm going to erase and rewrite the answer. All right, so let's do the second one. You notice that the bases are all different. You got a 3 and a 2, and 3 and a 2. I mean, personally, again, because the bases are different, you can't just multiply the bases to make them the same. You notice that there's a 3 in the numerator and 3 in the denominator, and there's 2 in the numerator and 2 in the denominator. So let me repeat in case I tongue twisted myself. So there's a 3 in the numerator, 3 in the denominator, there's 2 in the denominator, and 2 in the numerator and 2 in the denominator. With that being said, you could simply just subtract in terms of the same basis. So 3, 5 minus 2 equals 3 to the power of 3, 2, 8 minus 2, 3 equals 2 to the 5th. So the final answer should be now be careful of this. This is what you got to be careful about. Now, you could leave the answer in terms of 3 to the 3 times 2 to the 5th. You could leave it like that, because essentially that's what it is. Because when you use the division rule, you just subtract, and because they are different bases, you can't do nothing with them. So you just leave it exactly like that. All right. I'm gonna do the third one, and then you guys gonna do the fourth one. So let's do this. 5x to the 3 times 3 to the power of 8. Now here's what we know. Because we see a division sign and we see an exponent in the bottom, using the exponents, we know that that's the negative rule. So you could rewrite this as 5x negative 3 times 3x to the 8. Now, let me ask you a trick. Now, this looks tricky, but it's not. Now, I know you guys want to think, well, the bases are different. The bases are the same. I know you guys want to look at the numbers, but you have to remember when you're looking at this, which one has the exponent attached to it, the number or the variable? And you're going to realize that it is the x. The x is the variable. With that being said, you can multiply the coefficients. You can multiply these. 5 times 3 is 15. Exponents be the same. Now you can subtract. Negative 3 plus 8. Now pay attention, my people. If I owe you, being a negative sign, $3, but I paid you 8, do I still owe you? No. Do you owe me? Yes. How much do you owe me? $5 for my change. Bam. That is how you solve that problem. Alright, let's try 2 to the 13th power over 8. Bases are written differently. So again, with that 8, you have to write it to the same base as in the numerator. To do that, you have to do this. Let me erase that. So if I got 8, if I write this as 4 times 2. Remember, I have to write it in terms of prime numbers because the smaller base is a prime number of 2. So I have to have the same basis. So, how we reduce the 4? Because we know that 4 is not a prime number. 2 times 2 makes it prime. And then if I break down another 2, so it took me how many 2's to get to 8? 3 2's. I know some of you guys want to think 4, but it's 3 2's. So now we could rewrite this as 2 to the 13th over 2 to the third power. And when you subtract that, you get 2 to the power of 10. Well, I guess I decided to be nice enough to do it for you, huh? Oh well. So it's your turn to try this on your own. So this is independent work. And I personally don't need for you to get involved with another person. You guys are smart enough to figure this out on your own, so do it. And of course, I am walking around just seeing what's good. So if you're not handling business, you already know what's going to happen. So it's okay to make mistakes because we learn from them. So get to work. I give you 4 minutes and I'm pausing the video. Alright, welcome back. Now, I know for a fact that some of you guys are trying to fast forward to the video just to get the answer, just so you could chill. So, instead of reviewing the answers in the video, we're going to discuss it in person. So, I'm not doing this for you at all during the video. So, I guess you thought that I was going to do it. Sad on you. Group work. It's time for you guys to get to your groups and figure this out. You can work with a person. You can work with a person or two, but please be aware that I am walking around monitoring what's going on. I'm not doing this one in the video, so I'll be monitoring what you do. I go over it and then I'm moving on. So pausing video. You guys got a few minutes. Get to work. Welcome back. Again, as I told you, I'm not going over this in the video simply because many of you guys not taking this serious enough. You're waiting for me to give you an answer, and I will surely send you to summer school before I continue to do that. Alright, some more good work. Now, before you try to work this again with your partner, I need one partner. I don't need 20, 30, 2, 3, 4. That's not going to happen. So one person, if you don't have that one person, I guess it becomes solo work. Failure to comply will result in point reduction. Now, before we start, I want to help you out. In this problem, you see that there are two laws combined together. Please be aware that what we've been doing so far has been so simplistic. I know you guys want to just think, okay, just do one law. You have to do more than one law. Always remember that it's not as simplistic as what we did in the fall semester. So, good luck. I'll go over it in the video for you. Some of it, but not all of it. So get to it. And again, please don't fast forward this video if you work in the group work. Pause the video now. Welcome back. Now, did you guys actually thought that I was just going to give you an answer to that? No. So remember, with this, it is going to be the law of division, 0, law, and multiplication law that you have to use. I'm not giving you the answer, or at least not in this video. Alright? So here, what law of exponents have you had to use? Well, we know it's the 0 law and the power law. Alright, now I'll do this one with you. So here, write that expression in the simpler form of the equivalent to the given expression. I'm not doing that one for you because you guys know if you see a negative exponent, you know what to do. So you tell me. So what is the value of this one? Now this is complex. So remember in the beginning of the video when I told you that x is understood to be x to the power 1 or 3 or any number and understood to be 3 to the power 1. Now you have to figure this one out, finding out the value of it. So let's use the law of exponents. So we know that's 3 to the power 1. We had no numbers outside the parentheses, so it's not power law. And we know that 10 to the second power is understood to be 1 to 10 to the power of 2 using the negative law. Now, this part, you tell me what you got to do. How would you take care of this problem? What about multiplying fractions? You know that a whole number could be written as a fraction. So you know like 6 could be written as 6 over 1. 1,000 could be written as 1,000 over 1. And then from there you multiply across. So you guys do that. Tell me what's up. And then ask me then answer my question about 10 to the power of 2. So if I'm saying 10 to the power of 2, if I'm telling you 10 times 10 essentially is 10 to the power of 2, what would that be? What's 10 times 10? Alright, good job. So With that being said, that would be 3 to the power to 3 over 100. Now, can I leave you with this answer? You can. I could leave you with that, but that won't quite do it. So remember how I do this as point one. How do I do that? Alright? So write the complete well, before we continue, please note that this question that we just did, that is very important. I will be quizzing you or something like that, so please, 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 please work it out. Write the complete expanded form of 4 to 278 in exponential notation. I will do this one for you too. And I guess for now, this is not good work. I'll do this one. So in this case, in exponential form, you have to do it exactly like this. I'll explain why along the way. So remember about the exponents, the numbers, the decimal forms. So with place value, if this is -1, any numbers behind the decimals are known to be negative exponents. So that's 1 to the 10th times 7 10 to the -2 is 10 over what? What would it be? 100 times 2 10 to the -3 equals 1 over 1000 times 8. And then 4 times 1. So due to the space, you should simply have to just write it out like that. I will definitely be asking you something like that. So in the homework video, I'll help you out with that. So those two are very important to know. So let's move on. So what's next? In the next video coming up after this is the scientific notation video. And then, of course, radical videos, introduction to quadratic equations, all homework, tutoring, instruction videos, and homework help videos are in the Google Classroom. If you need assistance, you are responsible for getting the assistance.